Let's say this is our Earth. There it is. So if there were no objects around the Earth exerting a gravitational pull, the water would be uniform around the Earth, like so. There would be no tides. But there are objects around the Earth. We've got the sun, which is really big, so it has a big gravitational pull, but it's a long way away. The moon is much smaller, so it has a smaller gravitational pull, but it's very close. That means the moon is the biggest influence on our tides. So let's get rid of the sun for a moment so that we can consider this relationship between the Earth and the moon. And what's going to happen now, the moon's going to pull on the tide, and we're going to end up with a high tide on the part of the Earth that's closest to the moon. So as the Earth turns, the Earth's going to turn through that bulge of water, which is the high tide. Now, there's another high tide on the opposite side of the Earth. And that's because the Earth and the moon wobble around each other, and there's a bulge of water thrown out on that side of the Earth, as well as the tide that gets pulled up by the moon. But why is it that we get our biggest tides at the new moon and the full moon? Let's bring back the sun. And what you might notice is that now we've got an alignment between the sun, the Earth, and the moon. And that means the sunlight is actually shining past the Earth to light up the full face of the moon. That's what a full moon is this alignment. It also means the sun's pulling the water this way, the moon's pulling the water that way, and our tides end up being bigger than usual. And that's what we call spring tides. Now, these spring tides also happen at new moon, when the moon is between the sun and ourselves. So again, alignment this way and alignment that way both create spring tides. And here it is, the high tide. When I think about our nearest neighbour, the moon, and how it's helped me to make a living as a diver and as an astronomer, it's no wonder that I look up in the sky and I just marvel